So now we're going to talk about ICS and PM. Of course, I told you PM's been discontinued. The only reason I say PM is for the benefit of you guys that are out there in the field, like a new plant installation, I won't talk about it because they're not going to see it, they're not going to have it. But you guys are going to run into that. The dead giveaway there for a PM is the flanged connections. We've moved away from that to the welded, okay? So if you see that, it looks like that. Now, you might say, well, what about the square top? Well, that doesn't, because you can see the small ones here, we have the square top, and then as you get bigger, it goes to the round top, so. But the flange connections will give it away on that. They work very similarly. And this is the family. Again, I'm repeating this because it's really important. It's the way our family valves work. You've got a body, you've got whatever that function is, and we'll talk about some of those more in detail later. We've already talked about one, ICSH. So you can see that this particular function module works with that ICSH. It's similar to the ICS Pilot valve. The only two unique ones are the other two, the ICM and the ICLX, which I haven't covered yet. Okay, so body, function module, depending on what it is. And we say function module because it depends on the function. It's not going to be the same for every function. And then the top cover, again, this is for ICS strictly in the ICV family. So we're talking about a regulator valve that's going to do something, do several multiple things. Then you've got to have what we call the pilot part of the ICS valve. So this is actually what's going to do the control of the regulating. And you can see there's a variety of ones there. I'll just highlight them there. There's an inlet pressure pilot. There's an outlet pressure pilot. There's a differential pressure pilot. There are solenoid pilots. We talked about those. And then there's a new one, not to confuse you more, there's a brand new one called the CVE pilot. And that works with an ICM motorized valve. We'll talk about that in just a little bit, but it's not being used out there a great deal. So I just want to touch on it so you guys are aware of it, but you probably won't run into it. And it's that funny looking one right there. The way you can tell it, I'll show you that in a minute in a picture. Okay, so the basic operation of the ICS, we're going to use the PM valve as an example simply only because schematically it makes it very simple. Okay, so we have, if it's a single pilot cover, it's simple. There's one pilot hole. You can only do one thing. You could put an EBM solenoid in there. So now you got a solenoid valve. What happens is the solenoid energizes. It opens inlet pressure to the top of that piston, opens the function module. It's that simple. It's that straightforward. That's the simplest form. Now, where would that go? Well, you only got one pilot, so pilot hole. So it's going to be actually in the P because knowing that it helps you understand when you go to the 3. Okay, so when you go to the 3, you've got 3 holes, let's say, in this top cover. So you've got a P, an S1, and an S2. P stands for parallel. So what that means is that port is in parallel with the inlet pressure. So it always sees the inlet pressure. Okay. So if I put, let's make a simple pressure regulator. So I've got, before we go to finish with 3, we'll say I've got one pilot and I put an inlet pilot pressure regulator in that hole. Okay? Then what's going to happen is it's going to regulate the inlet pressure to that valve to whatever the spring tension setting is on that pilot. Okay? As the pressure drops, it's going to open and increase to the top, open the valve. As the pressure increases, it's going to close the valve, and it's going to sit there and regulate to the pressure that you set on that pilot. You'll see that better here in a minute when we get to the pilots and show the picture. But the little diagram there shows you P always sees the pressure because it's a ring all the way around. So before we go any further, I want to show, this will simplify it for you. should have opened this up earlier. Maybe I forgot to do that. This is a basic ICS 25. The simplest that we've got, one pilot hole. You can see that this is a little different from the SVO line with the ID tag, but it is up there. And that's an important thing to identify this valve. It has everything up here that you need to know, with one exception. And that is the size, if there are multiple sizes available. And that's the size of the function module. Okay, that's gonna be usually on the side of the valve right there when it's separated. So this is the function module. I put oil on it, so that's why it came out. Otherwise, I would have had to use a puller. Okay, so there's the function module. You see it open. Okay. How does inlet pressure always get seen by the P port? And if you put the valve like this, like this, like this, like this, it doesn't matter. It's because of that angular ring around there. All the way around there, you see that? That's going to pick up inlet. That's going to pick up inlet pressure. Okay, and it's going to always put it here to the pilot, so that this P port is always going to see that. Okay. Yeah, I probably won't pass this around. You guys can. You can see it from here, but you see the reason for the holes in the gasket, right? Because that's how that can work. Go around. All right, so that leads me up to the fact that S1 and S2 are in parallel. I mean, in series, excuse me. You got the parallel port to inlet, and then you got series 1, series 2. What does that mean? Well, that means something has to happen before it's going to pass on from S1 to S2 in series. So, P always gets inlet, okay? Off of that branches to S1, okay? So whatever's in S1, it's either going to pass that on to S2 or it's not. And S2 is either going to pass that on to the top of the piston or not, okay? The key to this is that you have a cap and you have a blanking plug or a stopping plug, I call it a blanking plug, that you don't see here. I don't have a picture of it here in this diagram. But it can go in there to either block or open the flow of pressure. Okay, so ICS is closed. You can see here, this is a basic picture, so you got pressure on top of the function module, okay? And it opens, just like I showed you when I held this, just like that, all right? And it tells you that the top cover can be rotated and it doesn't matter. All right. One thing to point out, I meant to point that out, and that is that, I get this question a lot actually, the way that valve opens, you can see that if you were to have back pressure, say you had a higher pressure on your outlet than you did on your inlet, it's going to relieve. It's going to relieve. Back pressure relief. This valve will do that. If it needs to do it. It's not common. I get the question a lot that people are wanting to use it in an application where they say they've got a situation where they're going to create a higher pressure periodically in their outlet, and they want that to relieve. They don't want it to pop a relief valve. It will back relieve. Only because of the configuration of that valve. It's not true with all of our valves. It's only true with the ICS pressure regulator, because that's the way that works. Okay. It's just something to point out. Okay, so we talked about the pilots. I'm not going to go into detail on them. They're self-explanatory, okay, as far as what they do, their function. The key here is I want to show you that how you will notice the new one, the CVE, which is a pilot that is controlled by electronic valve, which would be controlled by a PLC, some signal. That could be a variable pilot, okay, if that makes sense. It doesn't have to be, but it could be. So depending on what the 4 to 20 milliamp signal is from the PLC to this actuator, that setting can actually change. With these, under that cap, there's a spindle. You can adjust it, but it's a fixed. I mean, you adjust it, you leave it, and away you go. it's set at 50 pounds, it's gonna regulate to 50 pounds, okay? Whereas the CVE, it's used in applications where you're wanting to vary let's say you want to vary the evaporator pressure and temperature over some different operating ranges. I see it a lot in ice cream, manufacturing of ice cream. Ice cream machines use the old style, which we don't talk about anymore, and the CVE replaced it. But it uses an electronic valve. It's called CVQ. We don't do it anymore. The only problem I see with this valve, and it's unfortunate, but it's just the way that it is the head clearance. And you can see that. I mean, it's obvious. It can't be overcome. Okay, I'm not going to dwell on this either because you guys understand this. I'm sure the spindle adjustment clockwise is going to increase spring pressure. Counterclockwise is going to decrease spring pressure. That is what makes your setting, and it doesn't matter whether it's inlet or outlet or differential. The key is that say with differential, you gotta have a reference pressure for that differential. That's the key. The others, you're either inlet, outlet, or you're an EVM solenoid pilot that just simply the solenoid's energized and it opens, and the solenoid de-energizes and it closes. It's that straightforward. We have different ones for different pressure settings. You can see that. Here's the differential pressure pilot. This is the old one is on the right. This is our new one today. This is what we have. And this is a simple version of it, the inlet. I'll pass it around. You can take the cap off the top. You can see it, whatever you want to do to it. It's simple because it's inlet and it only has one signal. It comes in the bottom through the outside holes, and then it feeds into the function module cavity through the center hole, and that's how it works. This one, you can see there's two connections. One could be a gauge, a pressure gauge. The other one's going to be your reference pressure. So I've got my inlet pressure coming here, okay, into the cavity for the spring adjustment. And then I've got my reference pressure operating on the diaphragm down on the top. So those two together with that spring setting are going to do a differential pressure setting, okay? Without that reference pressure, it's not going to work. So it's a common question with installers that maybe they don't know, but inlet is the simplest one. You just screw it in because it picks up the inlet pressure. But there's an outlet and differential. There's a little bit more to it. We'll see that. So here's the outlet. So what do you think if the outlet pressure regulator is operating on an outlet? I don't have an outlet pressure regulator, but you'll see that it needs a reference pressure by itself. The outlet, it's not going to have it. So where's it going to come from? The outlet line. And I've gotten phone calls, unfortunately, from installers, from contractors. They call up and they say, yeah, my CVC is not working. And I'm like, well, what size pilot line do you have? And the guy will go, what pilot line? I was like, well, there's a connection on the pilot and it's got to come down to the outlet line. And they're like, wow. So it happens occasionally. I'm not going to cover these. This is really straightforward. It's a simple valve, solenoid opens, closes. It's really that simple. The only key to it is there's a normally closed version and there's a normally open version. So you might want to know, how do you tell the difference in the two? The normally open has an extra dimple. You see it there in the picture? I've got an example of one right here. This is normally closed, and this is normally open because it's got the extra. And the reason for that is how the armature works. Because it is normally open, that dimple is necessary for the armature. So it's open, and then when you energize it, it actually closes the valve. And there's a dampening orifice available. It comes with these devices. It's rarely used. It relates to delta P, and that's pretty high. If you have an 87 psi or higher, then you may want to use that dampening to make this thing work better. I've never actually seen one used. And here's the CVE, the one I said. I'm really not going to spend a great deal of time on this, but it has a regulation range, and it's going to be looking for a 4 to 20 milliamp signal to operate within a range or in a small range But it does have limitations, and that's why this chart is shown, so it comes with the instructions. The opening of this thing must be limited to 23% minimum and 90% maximum. The reason for that is the limitation on the CBE itself. It's the spring and the regulator part of it. It can be damaged if you operate outside of those. So you want to make sure that you put where you want to operate your evaporator pressure / temperature. You got to get in where you want to be, and that chart helps you get to that. So this is something you're probably not going to run into. You never know, you might. It's precise regulation. You might ask why you use this. Precise regulation, and it works fast. It's extremely fast. This is just a breakdown of our ICS valves. We go from ICS 25 to 150, which is a 6-inch. 25 is a 1-inch. I don't know if you're aware of that. The 25, all these numbers are millimeters for European. So 25 millimeters is 1 inch. And the ports, you see the port sizes. So the ICS 25 is kind of the unique one. It's the one I have here as an example. It just so happens this function module is, you look on top here, it's a 25-10. So if it's a 25-10, that means that's a 3/8 inch port in that. It's a 1-inch valve, but it's a 3/8 inch port in the valve. This is common variations. Okay, so we've got different things that we can do with this ICS valve. And we'll just look at these real quick and then go through them. We talked about the solenoid. That's the most basic one, and it's done. I actually had a job this week actually that used a bunch of them. I'd never seen that before. Literally every solenoid they needed, they put an ICS valve with them. It was amazing. I'd never seen so many of them. Then you've got the standard, which is just an inlet pressure regulator. You've got an outlet regulator, a differential regulator, and then the motorized regulator. That's with one pilot. Then you can get complicated with 3, okay? So listen carefully. You can have an inlet regulator, then you can have electric shutoff. So when the solenoid energizes, it shuts off, okay? Inlet pressure regulator with force wide open. Okay, so instead of closing, now the valve is either going to regulate off the pilot or it's going to be forced wide open. You kind of get the idea. There's lots of things you can do with these. You've got a dual pressure regulator. Okay, so that means you got, in the de-energized position, it's going to regulate off of one pressure. And in the energized condition, it's going to regulate off of another pressure setting on another pilot. Okay? And then you've got an outlet with electric shutoff. You've got differential with force wide open. We could go on and on. The last one being motorized regulation with mechanical CVP pilot backup. So how that one would work is with power energized, it's going to regulate off of that electronic valve and the CVE. If you lose power, you're like, okay, this is critical. If you lose power, I got to have something. So it's a manual pilot regulator. When you lose power, it regulates off of that other pilot in the manual, the mechanical, okay? Some examples. So here's an ICS 25-20 STD, we call it inlet pressure regulator. This is used on a lot of different things, but the picture is a thermosiphon relief regulator. It can be used also as evaporator pressure regulator, defrost relief regulator, pump relief regulator. There you go. There's lots of examples. Pressure gauge connection. We typically we recommend that you would want to put in we talked about the purge valves, the gauge valves that are back there. This is what you would want to do. Again, unfortunately, it's a G-thread, so you're going to need. You can see the adapter there. You're going to need an adapter with an aluminum washer. It comes with the purge kit or gauge valve kit, and then you just screw that in, and then you run to your gauge. And you can do that on all these ICS applications. But again, the key to it is that G thread. You got to have that adapter, and luckily it comes with the purge valve. Okay, here's the one that I told you about. So this is an outlet pressure regulator. This is the line in red was the line that they overlooked. I mean, it's clearly marked, it's in our installation instructions. The guy, I guess, didn't understand and he didn't realize, so they basically were, it's kind of bad in a way in the case that this guy called in, because they were already started up and they were trying to run and they're pressurized, and he's like, okay, so I gotta tap into that outlet line now and run it up to the outlet pilot. And it's like, yeah, I'm afraid if you don't do that, you're not going anywhere else. You're pretty much a dead stop. So that's just something that I like to emphasize in these.
What keeps you guys from putting that in the valve body itself?
The function of how it opens and closes the pilot. Yeah, again, inlet pressure regulator, it's pretty easy and straightforward, but now you're actually regulating an outlet pressure to that pilot, and it becomes a little complicated. It seems like it would be simple, but the design engineers tell me it's not easy to do. It's easier to.
No valve does that. On the outlet, they always do external.
Yeah, it's not, it just doesn't, it's what you're gonna see. And we've actually been pushing Denmark to come up with it, and they're actually saying they're gonna come up with something, but it's gonna be on an ICS valve station. So a module ICS control which we'll get to later, that you'll see that you can do all kinds of things with ICS valve stations. And somehow in the mechanics of that valve body of the valve station, they think they're actually going to be able to do something internally, so we'll see. I don't know, it hasn't been released yet. They got prototypes out there of it. Okay, so here's an example of what it looks like in real life. That's an outlet pressure regulator with electric shutoff, okay? So when the coil's energized, the valve's going to regulate according to the set pressure, okay? So energized, set pressure. When the coil's de-energized, the valve's going to close. The reason the valve is going to close is because there's no pressure from the inlet side down on top of the function module. If there was no blanking plug in S2, then when you de-energize, it would open the valve. That's how that works, okay? So you'll see that here. So you got inlet pressure regulator with electric shutoff, okay? The key to that is the blanking plug in there. We're going to move along here because it's getting, okay, I think you guys get the idea. So you've got different configurations. We give them letters, names. So here it's going to force wide open. So what do you see on this diagram that allows that force wide open to happen? What's missing on this one that was on the other one? And it goes right here. The blanking plug, it's gone. So S2, basically when pressure comes to S2, it's got a direct shot down onto the function module top, and it's going to force it wide open. It can get, I'll be honest with you guys, some of these can get really actually pretty complicated. They really can. So here's a dual pressure regulator, okay? So coil energized, the valve's going to regulate according to the lower set pressure, okay? And when the coil is de-energized, the valve's going to regulate according to the higher set pressure. The only key to this is the pilot in the P port has to be the higher set pressure. If you reverse those, it won't work. Okay, so P has to have the highest set pressure, whichever one's the highest. Here's just an application example, okay? So you're for pump pressure control. And you see here's our NRVA inline check valves, the piston valve. Here's the pumps, okay? Just an example of how a regulator could be used in that to regulate pump pressure. And here's the funny one. This is all mounted on a large ICS. So what you've got here is that backup one that I was telling you about, where they can do electronic regulation when they've got power, but when they lose power, okay, to this, then they can do mechanical backup here on the P port. They've got the mechanical regulator that they can set to. Now, keep in mind, now you've lost your regulation, but at least you can have a safe set pressure for operation if it's critical, which is why they would do that if there's something critical about it. Here's a good one. This is a good one. I actually saw one of these this week for the first, I've never seen this. I saw one of these for the first time where he's got an outlet pressure regulator and you can force wide open and then you can have shut-off feature as well, okay? So when both solenoids are de-energized, the valve's closed, no refrigerant. When S1 port is energized, refrigerant will pass through the valve, and then when S1 is de-energized and S2 is energized, or excuse me, P port solenoid is energized, the valve will fully open. Okay, so you can either have outlet pressure regulation, mechanical, you can have forced wide open and shut off. What is really interesting here is how you have to make sure that you're using the right ports, and that's the part that actually gets a little confusing. So if you walk up to one of these, I'm going to give you a quick way to know which one is the P and which one is S1 and S2. They are marked, but just in case. So the P is always off kind of to itself and typically has a protrusion or a slight protrusion off the cover. Then there'll always be a gauge port, but on the 3 cover, it's at an angle. You see it here at an angle right there. It's always in line with S1 and S2. You can sort of see that. I wish I had a 3 top, but it's just, they get so big. But you'll see it, it's literally in line with that gauge port. And that's how you can tell. Here's one where you could actually have an external pilot connection. So we could actually, there's 2 choices, a threaded and a welded. So threaded, welded. Okay, you could actually do this. Now, keep in mind, I would have a three cover one here for this, but okay, screw that in, and now I can take it externally, and I can do more with it. I can actually put another pilot and a solenoid there. It can even get more complicated than this, guys. I mean, seriously, with that external CVH coupling right there, it's called a CVH body. You can go crazy with this, and some designers actually do. I've actually seen one recently here that I'm scratching my head on, and I've really got to do some studying. But it was an outlet pressure regulator with forced open and close, but the pilot was not sensing outlet pressure. It was sensing another pressure in the system with an external line. And I'll be honest with you, that logically it makes no sense to me, but maybe there's something I'm missing, and I hope it is. So I've got a head scratcher now that I need to look into. But if you think about that, it's like that really doesn't, because typically you would want to sense something on what the valve is actually controlling, not on something clear, in another part of the system. So I don't know. It's probably something I'm going to learn, get a lesson from. I'm pretty sure. And we talked about the operation of the manual stems. I need to cover it. You could just see here that why in the standard 90% of the time with Danfoss ICS valves, it's going to be what you would think it was going to be. It would be the manual mode is spindle all the way in clockwise, so it's going in and moving this down, and then out for auto. Okay, clockwise, counterclockwise. Excuse me. Okay, installation and just some things to know here. On the small sizes, we typically, just because of the small size of the valve and the components, you guys don't need to know this, but it's interesting that we want the valve to be taken apart generally on small valves before you weld it, and on large valves we say you can get away with it. Generally, what I tell people is either take it apart before you weld it or wet rag it. That's what I say, because it's just me. How many of you guys have seen one of these before? Yes, okay. It's called a multi-function tool. It's pretty cool. I'll go ahead and show you this. So one of the one of the main, functions of this would be here. If I hadn't greased that, it would have been helpful to me. But in my case, I was able to dump it out, because that O-ring. But I've been on jobs where literally, you think you're never gonna get this thing out, and it's just simply because it's been in for a while. Okay, so you just use that, and then a screwdriver through here if it's really hard, and you just lift it out. So it's a function module removal tool. It has 3 functions, actually. The other one is hidden. It's inside here, inside where the magnets are. So there's a function we'll talk about later with the magnets. But then the other one is if you got it with you and you got a manual opener, stick it down on there. Okay. Yeah. Okay. It's inside there. A lot of people don't actually notice that and see that. So it's a nice tool to have if you're working on this stuff. And I'll show you the third one when we get to ICM Valve. We also send with the function modules these, okay, which you could use to pull that out as well in a pinch. I mean, I don't particularly like these, but hey, if you don't have the function module, that works. Okay, so the ICS Spare Parts is very similar with one minor exception to all our other programs. So you got inspection kit, which you know what that is, just gaskets. You got repair kit, which includes the valve seat and the piston ring in addition to the gaskets. And then the last one is just the function module. It's a complete function module. So if you choose not to rebuild this thing, you can actually just replace it. So how would you rebuild that? Well, they got flats on the top cover, and you got flat here on the seat body, and you just basically unscrew this thing. The seat comes off, and you can replace it. There's even actually a piston in here in the top piece, but you're only going to get the valve seat to replace it. And the gasket, you can see the gasket there, like the one I have. Okay, so we're going to cover this and take a break. Let's see what time it is. Oh yeah, perfect time. Okay. So this is ICLX. This is a special valve in the ICS valve family. It's different from anything that we have, and I have a small one here. This is a small one. If you can believe that, it's pretty heavy and big. ICLX gas-powered valve is used typically as a suction stop valve, okay? And particularly when you got hot gas defrost in the system. So we'll go over that. It's a normally closed solenoid type valve, okay? It requires no pressure drop for the valve to open or stay open, okay? It's good for low temperature and used in lower temperature suction lines. Remember we talked about the soft start where the solenoids are energized in sequence separately, first one, then the second one. The unique thing about the ICLX valve is in that one, they're both the same, normally closed. You have a normally open one and you have a normally closed one here in the ICLX, and mechanically there's a reason for that in there. What's going to happen, here, let me take this out and pass it around so you can at least see what one of these solenoid pilots looks like. It's similar to the pilots, the pressure pilots, but just so you can see that. It only needs one electrical signal, so it's going to energize both of these at the same time, okay? The valve is standard as a two-step opening valve, which we recommend, but it comes with bolts that you could actually go inside of the function module and convert that to a single-step valve. If you were using it in some application where you didn't care, you didn't need 2 steps of opening, you can do it. It's easily changed. Okay. The thing to point out here, the key to this valve, and it can be major for I've seen it in some situations, and that is the fact that it's gas powered. Okay. Hot gas pressure to here is what opens that valve. If you don't have that, that valve is not going to open. It's that simple. So let me give you just an example to illustrate that with a call I got a couple of months ago from a job out west somewhere. It's crazy, but you never know what you're gonna get. The guy calls and he says, yeah, we've got all these set up, and our ICLX valves are not opening. I mean, they're not opening. So we're manually opening them, but it works fine, but we can't do that. Like, okay. Well, you have the gas pilot line going, you know, what size connection do you have? He had it, and it was there. I'm like, well, how do you know you got pressure there? And he says, well, we do. We know we got pressure there. I mean, it's connected to a pressure line. And I said, but where is it coming from? And he said, it's coming from an ICS valve station. It's the hot gas valve station. I said, is it upstream of the solenoid valve for hot gas, or is it downstream of the solenoid for hot gas? Because as we get into ICS valve stations, later guys, you're gonna see these side ports, there's multiple ones, and there's a reason for that, because in some cases you don't want it to see pressure until the solenoid's open. In that case, you actually want it to always see hot gas pressure, and he had put it downstream of the solenoid valve, and it needed to be in the side port upstream of the solenoid valve. So it would see hot gas pressure all the time, it didn't matter. Because the valve is not gonna do anything with that hot gas pressure until you tell it to in your defrost sequence. Okay, we'll get to that in the, okay, so we talked about this pressure rating, differential, opening pressure differential for the valve. That's limited by the external gas pressure that's coming in. Okay. There's a seal, by the way. There's a fiber seal that goes on top of all of these. So the standard is two-step. Okay, so step one, it opens the valve to 10%. Okay, so you've been in defrost, and you're coming out of defrost, and in the suction line, you don't want to slam open 100%. You want to bleed. You want to have a slow start for out of defrost and back into refrigeration. This is the valve that actually does this. You can do it other ways. There's other valves to do it with, but this is one that does do it. So step one is going to give you 10%. Then it will open 100% when the pressure differential across the valve reaches about 18 psi, which is going to happen gradually. As you come out of defrost, then that's going to happen, and then that valve is just going to open up 100%. Okay. You can have it, you can set it up so that it doesn't do that. That's the standard way to do it. You want it to be in sequential step based on pressure drop. You energize both of them, it gives you 10%, and then when the pressure drops to 18 psi differential, then the valve opens 100%. There isn't an exception to that that we've actually seen. So you've got a pump liquid line, okay? In the defrost sequence, if you turn those on before the second step opens, before that 100%, and the pump pressure is more than 18 psi higher than the suction pressure, then it stands to reason that valve is never going to open 100%. See, that you've got to be really cautious with that kind of stuff. But you know, the guys that are setting up PLCs operating the defrost sequence, then they've got to be careful about how they sequence all that stuff and time delays and all that stuff. It can get kind of complicated. Okay, I'll show you how this actually works. So this is what the valve looks like. Do you see? I'll go ahead and point it out, but I'm just curious. Do you see a marked difference in the valve and the operation of it here for ICLX as opposed to a standard ICS valve, regulator valve? How the piston and the seat open? Oh, sorry. Okay, we'll see that here in a minute when we start actuating this thing. So now we're gonna say, okay, we're coming out of defrost, so both coils are powered. So the normally closed is open, and the normally open is closed. So you've got the gas pressure that we talked about, that's got to be there. It's gonna feed down into this piston cavity. We call this our main piston, okay, on the valve. The blue is the auxiliary. It gets up underneath there and goes against this spring, and it lifts that black piston, the dark piston, their main piston up. Okay, so it goes up. See that? What that does is that's gonna allow, in this blue piece, it's a cross section, okay? So there's a hole through that black piston moving up has opened up. So now what you're gonna have is you're gonna have 10% flow across that, okay? Across the valve, through that center piece. And only 10%. Again, both coils are still powered, okay? And now the pressure differential just dropped to 18 PSI. Now the blue piston brings the whole valve assembly up against that spring. Okay, that's the action that lifts that, and now you've got 100% flow across that valve, and that's, both coils are powered, so that's normal operation, that's refrigeration. So when you're in defrost, you're de-energized. Does that make sense? Regular operation, you're energized. Okay, so now the capacity is achieved, full capacity for the system. Now, you might have, typically this is gonna run off of, because it's wide open, it's gonna run off of whatever the house suction is, or you might have a suction regulator, but typically not in this, for using this, you wouldn't. Okay. So when the coils now, there's no power to the coils, okay? So that closes off pressure to here, okay? Outlet pressure is now connected to that cavity. So the valve's gonna close. It's gonna equalize and it's gonna close. You can manually open this valve, but it's backwards. And I think you can see, actually you can begin to see why. It's the orientation of the piston and how it operates. And in this case, if you want to manually open it, it's got to go up. And if you want to put it in auto, the stem's got to go down. So it ends up being backwards of 90% of our valves. So ICLX is the one exception. The other exception is that solenoid over there with the armature off to the side. It's called an ICFE.
Fails close, right?
What's that?
Fails close without power, right?
Yeah. And that's just the complexity of the inside of the valve. So when you open this valve to work on it, the reason this slide is just shows you all the parts. It's not simple like this. That function module is pretty complicated when you work on that. So you guys already know the answer to this question, right?
Wrong valve again. Normally open.
No, it's the one with the extra dimple. Yeah, it's normally open. Yeah. Normally closed is the one on the left. And orientation is pretty self-explanatory, really, guys. It's when you get into the big size valves, you don't want them on the side, but you don't want any of them upside down. The small ones, we say you can do sideways, on their side, just simply because the function module, the valve itself is not that big. But you can imagine one of these 105 inch, 6 inch, you don't want that on the function module on the side. It's going to wear in a bad way. So it's just not recommended. And installation, okay. So you can see here, these are not, so when you open up, you don't, it's not like this. So you don't have the beauty of that thread to pull it out. So get your screwdrivers, because you're going to be prying that thing out. It's, I've done a few and they are not easy to get out. It just takes a little bit of effort, but mainly because of the O-rings.
All the threads are British standard.
What's that?
Are all the threads British standard? Because
Not all the threads are British standard, no. No, we've got, in the small size things that we can have standard threads, SAE, and we can have NPT pipe threads. But in the larger valves, for whatever reason, everything is pretty much it's pretty much British standard pipe. What we try to do is we try to make sure that, like, if you're gonna order something where you're gonna be connecting something, we'll provide an adapter. Like if you order a purge valve kit for a strainer, it's gonna come with an adapter. Now, if you just order the valve, it's not gonna come with it. But if you order the purge kit or the gauge valve kit, or, you know, and we have them that way, it's gonna come with the gasket and the adapter and everything. It's an unfortunate, you know, thing that we have to deal with. Just, the reason I bring it up is just so that you're aware. So when you order something like that, maybe ask or think about it, wait, does this come with the adapter I need? If it needs one. So it's a good question though, and it's one that I wanna make sure I emphasize. Last thing I want is you guys on a job where you're ready to go and then you don't have the adapter you need. That's not good. So changing the small and the large to single step function is pretty straightforward. It comes with the valve. I've got one here on a small example. You can't see them real easily, but you see the Allen head screws there. There's small ones and there's large ones, long ones and short ones, whatever you want to say there. So the short, just think about it. The short one is what makes it a two-step valve. If you put the long screw in there, it couples those two pieces together and makes it a single step valve. It's really that simple. The hardest part of that is actually putting them in. You know, but knowing about it and understanding it is pretty straightforward. But yeah, it's there's a little bit to it, and then it comes with instructions on how to do that. And then the large one is just the size of the valve and the function module. I mean, guys, it's, you know, we're talking 6-inch valve. The function module is going to be bigger than anything I got here, including the size of the valve. Okay, and then I show this just, I mean, this is just you know, this is what we see a lot, progressing through from cooling to request for defrost, to defrost, and then stop defrost. So the request for defrost, the key here is that the ICLX or suction stop valve is going to be closing when you request for it, and closed before you actually engage the hot gas. You can see that right here. Okay. That's kind of a key, the delays that you need to have. Then it's in defrost, and then you can see when it comes out of defrost, that's where your suction stop valve is actually going to do that two-step gradual opening, and it talks about it right there in the remarks section. But anyway, this is kind of a rough recommendation of how it can work. Okay.